In this video, we're going to learn how to solve exponential equations. So let's jump right into the first problem. Solve 2 to the power of x equals 8. The idea here is to express the right-hand side as an exponent with the same base as the left-hand side. So we'll have 2 to the x equals 2 to the something. And we just have to fill in that something. And once we do that, it'll become very clear what x is, because they'll have to have the same exponents. Okay, so 8 is 2 to what power? Well, 8 is, so let's start with 2, and then times 2 makes 4, and then times 2 again makes 8. So 8 is really 2 to the third power. So now we have 2 to the x is equal to 2 to the third, and since the bases are the same, if these two sides of the equation are going to be the same, then the exponents need to be the same, x and 3. So that means that x is equal to 3. Alright, on to the next problem. Solve 3 to the y plus 2/3 is equal to 1. This is going to be pretty similar to the previous problem. We actually want to get ourselves into the same situation where all we have on the left-hand side is that exponentiated expression. So all we want on the left-hand side is that 3 to the y. We want to get rid of that 2/3. So let's go ahead and subtract off 2/3 from both sides. So we'll do that. 2/3 minus 2/3 will cancel. We'll just have 3 to the y on the left-hand side. And then 1 minus 2/3, we can work that out here. 1 minus 2 over 3. Well, 1 is just 3 over 3. And then 3 over 3 minus 2 over 3 is just 3 minus 2 over 3, or just 1 over 3. So 3 to the y is equal to 1 over 3. And now we're in a similar situation as last time. All we have is that exponentiated expression on the left-hand side. So let's keep it there. Let's keep 3 to the y. And we want that right-hand side to be equal to the same base raised to some exponent. So 3 to the y equals 3 to the something. What is that something? Well, 3 to what power gives us 1/3? That's what was originally on this side, so we have to keep it the same. 1/3 is just the reciprocal of 3. So the power has to be -1. It's 3 to the power of -1. And now we're all set. We've got the same base on both sides. And now we can just equate the exponents, y and -1. And we see that y is equal to -1. Let's move on to some more challenging examples. Here are some more examples. Let's solve this left-hand side first. Solve 2 times 4 to the x minus 32 equals 0. Our strategy is going to be the same as usual. We want to isolate that 4 to the x on its own side, get rid of all the other terms, move them all to the right-hand side. So let's start off by doing that. We want to get rid of the 2 and the minus 32, and the way to do that, first let's just add 32 to both sides. That'll cancel out the minus 32. And then we've got here 2 times 4 to the x minus 32 plus 32 cancels. That's just equal to 0 plus 32, which is 32. Now it's time to get rid of the 2 that's multiplying the 4 to the x. Now that's pretty straightforward. We can just divide by 2 on both sides. That'll cancel out the 2 there. All we have is 4 to the x. And then on the right-hand side, 32 divided by 2 is 16. Now we're in a familiar situation. An exponentiated expression equals some other number, and you know what to do. We want to keep that exponentiated expression the same, 4 to the x, but we want to rewrite that other number, that 16, as the same base 4 raised to some exponent. So 16 is 4 to what exponent? Well, 4 times 4 makes 16, so it's just 4 squared. And therefore we can conclude that the exponents have to be equal, so x is equal to 2. There we have it. Alright, next problem. Solve 5 to the x equals 1 over the cube root of 25. This one's a little bit trickier, but the idea is still the same. We want to get that right-hand side here to look like the base 5 raised to some exponent. So let's skip a few lines here to leave ourselves some room for work, but we want to get to a situation where 5 to the x is equal to 5 to some other exponent. So we just need to figure out what is that other exponent. And to do that, we'll have to manipulate this right-hand side a little bit. So is there any way we can start by introducing a 5 on the right hand side? Maybe 5 to some power. Maybe don't worry about the cube root for now, but just focus on the 25. Hey, 25 is just 5 squared. So we can write this equation as 5 to the x is equal to 1 over the cube root of 5 squared. Okay, great. So the 5 squared is good, and it's really just the cube root that's messing us up a little bit. But that's okay, because we know that roots can also be interpreted as exponents. A cube root is like to the exponent of 1/3. So 5 to the x, we can write the right hand side as 1 over that quantity 5 squared, and then to the exponent that corresponds to the cube root, which is 1/3. Now we can simplify this a bit using our exponent rules. So 5 to the x is equal to 1 over, exponent rules say that when you have an exponentiated expression raised to another exponent, then you multiply the exponents. So 1 over 5 to the 2 times 1/3, or just to the 2/3. Alright, we're pretty much there. Now we just want to get that 5 outside of the denominator of the fraction, and we know that one way to do that is to flip the sign on the exponent. 1 over 5 to the 2/3 is the same thing as saying 5 to the negative 2/3. And finally, here we are at the final step. We've got 5 to the x equals 5 to the negative 2/3. We've got the same base here, so the exponents must be equal. Therefore, x equals negative 2/3. So now we have a good idea of how to solve exponential equations. And in the future, we'll learn how to use this knowledge to solve real-world problems involving exponential growth and decay.